Hi guys, so this is a follow-up for our lab that we did today, the potato core lab. Before I get into the lab itself, I just want to remind you about the movement of water. So in this diagram, we can see that we have solute represented by pink stars, and we have water represented by orange squiggles. So I can see that this cell is hypertonic to the solution around it. It has more tonic solute, more solute than the solution does. So I know that water is going to move from the outside of the cell to the inside because there's so much extra water here, and this needs more water to balance out the concentrations to reach equilibrium. So all of these stars could use more waters in there to dissolve them, all of that solute. So you're trying to balance the concentration. So the water potential outside of the cell must be greater than inside if that water's going in. Water potential is high to low. So in the lab today, we were trying to figure out what the concentration of solute is in a potato cell. So we basically had a potato. Oh, you can't see my potato. So we had a potato. You saw me taking those chunks out of it, those little core slices, right? So we did that as a collection of cells. It's not an individual cell because one cell is so small, but that allowed us to put potato pieces into beakers of different solutions to try to figure out what was going on. So we wanted to know what the concentration of solute is. So I'm going to stick to the pink stars. So we don't know what concentration is in a potato. We can't just look at it and know it's 0.1 molar or it's 0.3 molar. We have to do something to try to figure it out. So it's a question to us. This is a question mark. So to try to figure that out, we took our potato cores, our multiple samples from the potato, and we put them into beakers of water with sugar containing different concentrations of sugar to try to figure out which most matched the concentration of solute in the potato. So we took our cores and we put them into different beakers. So we had our beaker that was pure water. So it had a concentration of 0.0 molar. So that means there weren't any stars in there. There's no solute in that. It's totally just water. And our potato core went inside. So you guys saw that this potato got larger, indicating that water went in, the mass increased. So that tells us that there's at least some solute in the potato cell. Because water went in, it got larger. We also had a beaker that was 0.2 molar. We had one with 0.4 molar. We had one that was 0.6 molar, etc. So we can represent that the 0.2 molar one has a little bit more solute than the pure water. So a couple of stars, a couple of solute molecules. The 0.4 has even more solute than the 0.2 did. So I'm representing that with more stars, putting my potato piece in there. And 0.6 molar has even more stars than 0.4. It's more concentrated. More and more and more stars. And obviously our 1 molar was our most concentrated. So in order to figure out what the concentration of this potato is, we wanted to put the potato in different concentration solutions to try to see at what point the mass of the potato doesn't change. So if the mass of the potato is not changing, that indicates to us that the same amount of water is going in and coming out, and so the potato is isotonic to that concentration. So we put it into the yellow, and we know that it gained mass. I think I'm just going to keep going. So we put it into the green, and it, for some of you, gained a little mass. For some of you, it stayed 0. So 0% mass gain or loss. And as we went further on, all the potatoes lost mass. So if we're putting a potato into 0.2 and it's about not changing the mass, that would indicate that that potato is isotonic to that solution at that concentration. So if it's isotonic, what do you know about the concentration? So it's going to be the same as that solution, right? A lot of you, however, did not have a perfect 0% mass change. So you had to graph your data. And, I don't know, can you see this? So, right. Nope. I'm trying. Yeah, okay. Well, zoom back out. Okay, so some of you didn't have like a point exactly on the 0% mass change line, if we had a line through our graph. So what you have to do is you have to draw a line of best fit that represents your data, and you kind of have to take a guess at where between 0.2 and 0.4 you think this line is passing the 0% change. So that's going to indicate to you that that's the concentration, that if you took a potato cell and you put it in that concentration, it wouldn't change mass, indicating that's the concentration of the potato cell. So depending on if you're looking at your data, the class data, I think that can range from anywhere from 0 concentration to 0.4 concentration. As always, if you have questions, email me.